This is the first question and simple calculation based. And if you observe, we have 2 square minus 1, then we have 3 square minus 1, 4 square minus 1, 5 square minus 1. What you can write this whole thing as 2 minus 1 into 2 plus 1, right? Then 3 minus 1 into 3 plus 1. Then 4 minus 1 into 4 plus 1, numerator. And 5 minus 1 into 5 plus 1. And the denominator is as it is 2 into 3, 3 into 4, 4 into 5, and 5 into 6. Okay. So from here, what we can say, 2 minus 1 is 1, this is 3, this is 2, this is 4, and this is 3, and then this is 5, this is 4, and this is 6. So we can cancel 1, 2, we can cancel 1, 3, we can cancel 1 more 3, 4 we can cancel throughout, 5, and 6. What we are left with? Only 1 over 5. So it's direct calculation, just use cancellation, don't multiply anything. Okay, use the cancellation. And this is how we can have the answer. Next one is, what is the smallest prime number, which is the sum of the 5 different primes? Five different primes and the smallest prime. So let's just start with 2. All the smallest we can list. Plus 5, 7, and 11. If we add it, okay, one by one. So we get 5 plus 5 is 10, and we have 17 or 18. So we get 28. 28 is not a prime number, of course, and it should be higher than this. Now, if we skip 2, okay, like we don't want to skip 3 because anyhow we have to add next prime number. So if we skip 2, we go to 13. So we can do minus 2 and we can add plus 13, right, to this. So this is going to give 26 plus 13, 39. 39 didn't work, I think. So what is the next number we can choose? Instead of 13, if we try 17, next prime number. And we have to take all these combinations. Like if we want to keep 2 and next, okay, nearest to 39 is 41 and 43. So I think this may help. 39 is not a prime number, so first of all, this is cancelled out. And what we can do to get 41 is difference of 2 is there. And if we keep 2 and we remove 3, that's the addition of one more value which will give you 40, right? And if you remove 5, no, less than, we are not going less. Yeah, we have to do minus then. It's not going to 40, 38 in that case. Now, let's try with the 70. So if we have 3 plus means 28 minus 2, that is 26 plus 70, 3, and we got 43. So 43 may be one of the options, but can we have 41? No, I don't think, because see, if you have to remove anything, okay, means if you take any combination with this, it's either going to be maximum 39 or less than it, okay, because if you remove 5, you keep 2, so it will be less than 39. None of the option is 39, so we are not going to consider it, and it's not possible also, most probably. So we'll consider 41, 43, 39. Now 41 is not possible because if you go with the 70, the lowest sum, okay, we are not going to include 13 higher number because we have to find the smallest one. So smallest means we can remove 2, right? This is what the smallest value we can have. For 41, if you observe, so if you subtract 41 minus 70, it's going to give you 4, 24, right? And for 24 to 28, you need to subtract 4. 4 we cannot subtract. We can subtract 5, we can subtract 3. So it's not possible. So 43 is the answer. This is the question. The figure shows a regular hexagon how many parallelograms are there in the figure. So you have to count all the parallelograms. So remember, with this space, how many parallelograms we can have. So with this space, we can have one, and we can have two. So two parallelogram we have, right? Now this two parallelogram is done with this one now, or we can have one pattern on this direction. This is the one. Again, we have this one. Again, we have this one. Again, we have this one. And we have this one, which is six, complete six parallelogram. But do we have anything extra? Yes. For example, let me, I don't think there is anything extra we can draw here. So this is the only number of parallelogram we have. Okay. So in one direction, you keep counting so that nothing is repeated, and we have the complete number. Okay. Question number 4. The diagram shows two symmetrically placed square with side of length 2 and 5. What is the ratio of the area of a small square to that of shaded region? So this is 2, this is 5. So the numerator is going to be 2 square, right? Because the area of the smallest square is a square, which is 2 square. And the shaded region, if you observe, so shaded region is like half. Okay, let us assume this is half. Okay, and this is going to be 5 square by 2, of course. And then you have to subtract 2 square by 2 because we don't want this area. You have to remove this area from here. So that is 2 square by 2, half of it. So we have 4, and we have 25 minus 4 divided by 2, which gives you 4 times 2 divided by 21, or 8 by 21. So this is the answer. Okay. Next one. Now we have to add all these values. And if you observe, the first one is going to be 100 by 101. And the last one, if you combine, okay, you have to combine last one. Then we have the second one and the second last one, second term and second last term, and we have 1. So this will give you 101. This is how we can combine it easily. 11 by 11 and 1, we get 3 directly, right? Don't do anything complicated. Simply combine so that they can simplify it easily. Question number 6. What is the value? So convert it into 2, power of 2, because all the answers are in power of 2. So convert it. 4 is 2 square. 8 is 2 cube. So this is going to give 2 to the power 8 times 2 is 1600 divided by 2, 1200, right? So 2 to the power 1600 minus 1200 is going to give 2 to the power 400. And this will be our answer. Question number 7. In 2021, a first-class postage stamp cost 85 paise and second-class postage stamp cost 66 paise. In order to spend an exact number of pounds and to buy at least one of each type, what is the smallest total number of stamps that should be purchased? So first class 85 paise, second class stamp is 66 paise. So first write the data, okay, all the data you have, write it down. Exact number of pounds and to buy at least one of each type, what is the smallest total? Exact number of pounds is if you multiply 0.85, let us assume this is x times and this is y times. This must be integer, and x and y are not going to be 0. Okay, this is what we have to take care of. So because exact pound we want. Now if you go through the multiple, 5 can only be either 0 5 means unit digit. 5 could be 0 or again 5, right? And 6 cannot give you 5 at the end, but it can give you 0. So if it can give 0, you have to find x plus y. So let us say 5. Okay, this is 5 times. Because I think it may help 5 times. It will shift by one digit. So we have 5 times means 30 and 30, 66, 5. So it's 30 and 30, so 33, 3.3 pound it will cost. If this is 3.3 pound, we want 7 here, right? We want 0.70 kind of thing. And in 85, if you go with the calculation, so 85 we have, next one is going to be 1.70. And we want 7. Okay, so 7 and 3 can be combined. So we have 1.7 means x is 2, y is 5. So we have 1.70 plus 3.30 because we want to shift it one time. Because if you want to keep it here only 6, so this unit digit is going to be 5 or 0, 5 or 0. So nothing will help. So you have to make it 0. And to make it 0, you have to multiply with 5. And this is the reason I started with this thing. And if you count it now, it's going to give you an integer, right? 5. So the total number of x plus y we have to find x plus y is going to be 7. 5 plus 2. Next one. Okay, question number 8. In the diagram, the outer hexagon is regular and has an area of 216. What is the stated area? So what we can do in this question, we can just take a point. Okay, and we know the standard values of all the trigonometric. Okay, so we will try to go with the trigo, nothing tricky. So if you observe it, okay, join this, all this region. Uh, say these two are congruent, okay, and if you join it, so these two are going to be equal. Now join this length. Now if this is A, okay, this is also going to be A, so this is A by 2. In this small triangle, I'm saying O, A, B, and C. So in this small triangle, O, A, B, what we can say, tan 60, this is going to be 60 degree. So tan 60 degree is A by 2 by AB. And tan 60 degree, it is in this is B. So we have to find 2B. Tan 60 is root 3. We have A by 2B. So B is A by 2 root 3. But we want AC. So AC is going to be 2B or A over root 3. So the larger hexagon, if you observe, larger hexagon is A and the smaller one is A over root 3. So area, like they are similar. Okay, so they are similar. And the scale factor, area depends on the square of the scale factor. Square of scale factor. And this means we have to use 1/3. Okay, so the area is going to be, so scale factor is 1 by root 3. So area is going to be 1 by root 3 whole square of the 2 means larger hexagon. So 216. So it's going to be 1 over 3 into 216, which is 7 times 2 times. So 72 is the answer square root. Okay. Next question. A light nanosecond is the distance that a photon can travel at the speed of light in 1 billionth of the second. The speed of light is 310 to the power 8 meter per second. How far is a light nanosecond? So it's 1 billion. So 1 billion is going to be like a million is 10 to the power 6 and billion one more 3. So 10 to the power 9. That's 1 billion. 1 billion. And 1 billion means 1 over 10 to the power 9. This is the time we have. So the distance is going to be speed into time, which means 3 into 10 to the power 8 into 1 by 10 to the power 9, which gives 0.3 meter, or we can say 30 meter. Okay, 30 centimeter. 30 centimeter. Multiply with the 100, so 30 centimeter. Next is question number 10. What is the value of x in this equation? So this is the quadratic equation. Cross multiply and we'll have the answer. So 1 plus 2x plus 3x squared. If we cross multiply, we have 3 times 3 plus 2x plus x squared. And this is not a quadratic because if you observe 3x squared will cancel out. So 1 plus 2x plus 3x squared. And this side we have 3 times 3, which is 9. 3 times 2 is 6x and 3x squared. This 2 will cancel out. Okay, so all the number one side on the variable one side. So 1 minus 9 equal to 6x minus 2x, which gives minus 8 equal to 4x. X is going to be negative 2. This is quite direct question. Next is question number 11. In the number triangle shown, each disk is to be filled with the positive integer. Each disk is on the top of the row contains the number which is product of the two number immediately below. We have to find the value of n. Now this is 2022 is given, so let's factorize it first. May help, I think. 2, 1, 1. And if you go through it, it's multiple of 3, right? So 3 times 11, again 3 times 21 is 7. And 337 should be multiple of something. Most probably. Because say, yeah, 337 would be here. And we have to divide it into 2 parts. What are the possibilities? For example, if I write 2, 3, and 337, this will make it 337n. So we will have n squared. So remember one thing. This will also have n. This will also have n. Let us assume this is a, this is b, so this is an. Okay, we're not going to factorize 337 because most probably it looks like prime, but we are not sure. And so what is our approach must be? an, bn, and this gives you abn square. Now, if you go with abn square, okay, there must be something perfect square. And if you observe 337 till 20, we know the perfect, all the things like 18 is the nearest one, 3, 2, 4. But 337 is not a perfect square, and any combination 337 with 2 and 3 will also not give you perfect square. Because this is not even number, this is not also multiple of 3. So 2 square, 3 square, we are not going to get. So n should be 1 there, and a is going to be 6, or anything, any combination of these 3 numbers you can take. Okay, and let's assume a is 6, this is 337, so this is again 6 and this is 337, and you have 2022, so n must be 1. Okay, so this n square, I think, can help to figure it out. Next one. Question number 12, what is the sum of the digit of the integer which is equal to this thing? So if you go with a plus b, what is a square minus b square? Simple algebraic identities is a minus b into a plus b. Now if you do 6, 6, 6, 6, how many are there? 3, 4. So 3, 4, minus 3, 3, 3, and again same 3, 3, 3, 7 times. And you add the same thing, 6 and 3. So we get, if you subtract, what we get? 3, 3, 3, 3, 3, 7 times. And if you add, we get 9, 9, 9, 9, 9, 9, 9, 9. Now, remember, anything multiplication with 9, we can't, okay, we are not going for multiplication, harder multiplication. But what we can do, we can add 1 and subtract 1. So this gives you 10 with the 7 zeros minus 1. And you're going to multiply 3, 3, 3, and 3, 3, 3, 3. And this gives you 3, 3, 3, 3, 3, and 7 zeros minus 3, 3, 3. And this is how we can multiply it quickly. It means everything. So you have 7 9, so 6, 6, then you have again 6, 6, 6 times, and 7. And you have 3, 3, 3, 3, 3, 3, and 2. Now we can add all this, right? We can just put 7, and this will become 3, and this will become 6. Means we have to add all the digits, right? So how many times 3? 3 is going to be 7 times, and 6 is also going to be 7 times we have to add. So this is going to give you 21, and this is 42. So our final answer must be 3 and 6. So 63. Okay. This is how we can multiply easily. A square minus B square. That's the trick. Next one, question number 13. Three rugs have combined area of 90 meters square. When they are laid down to cover completely a floor of area 60 meters square, the area which is covered by exactly two layers of rug is 12 meters square. What is the area of floor covered by exactly three layers of rug? Looks like a Venn diagram, right? Three rugs have combined area of 90 meters square. So if you combine three rugs, just put this joint way, you have 90 meters. Floor is 60 meters. So that's the Venn diagram we have. Like we have something like this. So ladies and this is the Venn diagram. So we have rug 1, R2 and R3. Now if you just add R1 plus R2 plus R3, it's going to give you 90. But if you add this way, minus R1 intersection with R2, means what is the common area with R1 and R2? And we again subtract R1 with R3, combined, means combined area with R1 and R3. And we again subtract R1, R2 intersection R3. And if we add R1 intersection R2, because see, if we subtract, so this will get subtracted three times. We have to add it. So this is the called inclusion and exclusion. So R2, R3. Okay, and this complete thing is going to give you 60 if you combine. Okay, so leave this part and now combine everything with this, you have 60 meters square. So the first one is 90, of course. Second one, if you observe this 3 unit, so this 3 is not going to be 12. Exactly 2 layer of rug is 12 meters square. So what we have to do here, we have to subtract it. Like we have to only count this part because this is exactly 2 layer. So with each we have to subtract one time this. Okay, and let us assume this is the common, 3 common parts. So we'll just write C. So R1 intersection R2 minus C plus R1 intersection R3 minus C and plus R2 intersection R3 minus C. How many times we have to subtract C? If you multiply with minus, we are adding it 3 times. We are adding it 3 times. So we have to subtract 3 times. And one time is already added. So this is going to give you 60. And this unit is not 12 meters square because this is exactly 2 layer. And we can write 90 minus 12 minus 2C equal to 60. Bring everything to one side. So we get 90 minus 60 minus 12 equal to 2C, which gives 30. 30 minus 12 is 18. So C is going to be 9. That's 3 rug area, common part, and this is 9. Okay. Next one, we can go through. Now the diagram shows KLMN. A second square PQR is drawn inside it, as shown in the diagram, where P divides KL in the ratio 2:1. So all will, okay, remember, this is going to be congruent because this is 2:1. This angle, this is going to be a complementary. This is 90 degrees. So again, this is going to be a complementary. So all are congruent by angle, side. Similarly, the third square, again with 2:1 ratio. The fraction of area of KLMN is shaded. So we have to find length, right? This is what we have to find. So let us assume this is 1, this is 2, length. So this is going to be square root of 5. Okay. Remember the complete length is 3. Now this is a square root of 5. Again we have, see 3, if you observe it, the bigger one is 3. And then with 2:1 ratio, we got root 5, right? And now again, if you go with 2x, and this is x, this is going to give you root 5 times x. And what is x? Say 3x is root 5. So x is going to be root 5 over 3. And if you, since we are multiplying x with root 5 again, so the smallest one is going to be root 5 by 3 into root 5 because this is x root 5. Okay, so we get 5 over 3. And the fraction of area now, fraction of area is going to be 5 over 3 whole square divided by 3 square. 3 square for the larger k element, and the smallest one is going to be 5 by 3 whole square. So which gives 25, 9, and 9 again. So 81. Okay. Is that next question? The hare and tortoise had a race of 100 meter in which both maintained constant speed. When the hare reached the finish line, it was 75 meters in front of tortoise. The hare immediately turned around and ran back towards the start line. How far from the finish line did the hare and the tortoise meet? Okay, so this is 100. So tortoise only reached 25 and hare has completed it. So 75 is there. So this is the tortoise first position and hare first position at the same time. And let's assume this is 10-second time. Okay, nothing wrong. Okay, you can just assume any time. So here speed is going to be 100 over 10, so 10 meter per second. And tortoise speed is going to be 25 over 10, 2.5 meter per second. Now it start going back, and tortoise is also going in the same direction, 2.5 meter per second, and here is going with 10 meter per second. Either you can use the relative velocity. Relative velocity is going to be add them 2.5 plus 10, which is going to give 12.5 meter per second. And how much distance we have to cover? 75. So we'll find the time. So the time will be 75 over 12.5. Okay. So this is going to give you 3. This is going to give you 0.5, or this is going to give you 6. 6 seconds. 6 seconds means how far from the finish line did the hare and tortoise. So from here you have to find. So just multiply with the hare speed, which is going to be 10 into 6, and this gives you 60 meter. So time is not important. It means time is like you have to consider any time. You can consider 10 seconds, you can consider 20 seconds. 10 is quite easy to calculate. This is the reason I took, and it will give you the same distance. Next, in question number 16, see if you know the standard graph, means almost all the standard graph we can plot. For example, if you observe x square plus y square equal to 1, which I think everyone knows, right? It's a simple circle equation. This is how it looks like. If you go with x cube plus y cube, means if you increase the power, remember, or x to the power 4, that is x to the power y to the power 4 equal to 1. This is how it will look. It will become more like outward. Okay, it will just try to push this thing outside. And if you go x plus y, now it's going to be inside. Use the mod because we are treating even function. So this is how it will look like. So when you do a square root, means you're decreasing the power, so it will go inside. Okay, it will go in. So when we do square root of x plus square root of y equal to 1. This is how it should look like. Since we need positive, so of course we have this thing, b. Now with the value, how we can define. So if you don't know this concept, okay, it's okay. Or we can do it directly also. Like y, if you take y equal to 0, of course 0 and 1. So these are wrong. This is a straight line, it's not going to be straight. Circular, this is not going to be. And B and C may be confusing, but remember, it's going to be symmetric about x equal to y, because you can switch x with y, y with x. So this graph must be symmetric. Whenever any equation is written symmetrically x and y, so it's symmetric going to be symmetric about y equal to x line. So this is direct. Okay, you can say either A or B, because this is also not symmetric. It's going this curve, and concavity, if you observe the concavity, it's different both the ways. So C is wrong, D is wrong, E is wrong. Directly you can say both are wrong, because say y is 0, x is 1, x is 0, y is 1. So D is wrong. It's not going to be a straight line. Now, what we can say about A and B, if you know the circle, A is not going to be the answer, right? Now, it must have this point, it must have this point. Now, the point is whether it's going this way or it's going to be this way. Simple. We can choose any point. For example, if you know the circle, this is 1, this is going to be 1 by root 2, comma, 1 by root 2. Okay. Because x square plus y square, x equal to y must be. So if x is equal to y, what we have? Half, if you square it, half plus half, you get 1. In this case, if you put x equal to y, which is this one, so either it's going to be this point, this point. So we have to assume, we have to find it. Okay, so now this is going to be half. In circle, this is going to be 1 over root 2. And in this case, it's going to be 2 root x equal to 1, root x equal to half. If you square both sides, we have 1 over 4, which is less, right? So it's going to be inside. And this is the result B square. So this is like direct drawing, but not only direct, we're still figuring it out, comparing all the 5 diagrams. Okay, and you can say from A and B, B must be right. Next, question number 17. The shape shown is made by removing 4 equilateral triangles. Okay, so these are the equilateral triangles from the octagon with length 1. What is the area of this shape? If you observe area related questions, okay, in SMC, even IMC also, they ask. And it's really important topic if you observe. Okay, so many questions from the area. Okay, now for the octagon, what is the easiest way to find area? Can we just make it this way? A square. Okay, and if you make a square, this side is 1, this is 1. Now by symmetricity, it's going to be 90 degree, and these two are equal. And if these two are equal, this is A and A. Okay, simple. A and A, this is going to be A root 2. So A value, which is 1, so A is going to be 1 over root 2. So this is 1 over root 2. This is 1 over root 2. So we have the area of a square. That's 1 plus 2 times 1 over root 2 whole square, which is 1 plus root 2 whole square. Okay, now what we need to subtract for shaded region? We have to subtract 4 times this area. This green one, we have to subtract 4 times. And we have to subtract this equilateral triangle area. Now, equilateral triangle area is root 3 over 4 a square, which is 1, or root 3 over 4. And area of that right angle triangle is going to be half times base times height, which is 1 by 4. And now we can subtract. So the shaded region is square area minus right angle 4 times and 4 times equilateral also. And if we do this, square area is going to be 1 plus root 2 whole square, which is 1 plus 2 a square plus b square, root 2 square is 2, plus 2ab, so 2 root 2, okay, into 1, that's 2 root 2. So 3 plus 2 root 2, minus 4, 1 over 4, right angle triangle, and root 3 over 4 for equilateral. 4 and 4 got cancelled out. 3 minus 1 is going to give you 2, plus 2 root 2, and we have minus root 3. So that should be B. Bye. Just go through it. Next one. The number x and y are such that 3 to the power x plus 3 to the power y plus 1 is 5 root 3. And again 3 to the power x plus 1 plus 3 to the power is 3 root 3. What is the value of 3x plus 3y? Now, this is quite symmetrically written. Then, what we can say, if we know 3 to the power y is capital Y and 3 to the power x is capital X. So can we write x plus 3y is 5 root 3. And this one is going to be 3 times x. Okay, 3 times 3 to the power x plus y is 3 root 3. Right? And to find, we have to find x plus y. Just add, okay, both the equations. So we have 4x plus 4y. 5 plus 3 is 8 root 3. If you divide it by 4, that's going to give you 2 root 3. And this is our answer. Quite quick. And I think if you, okay, never skip this type of questions, which is really quick to solve. Next one. Question number 19. How many pair of real number x comma y satisfy the simultaneous equation x square minus y equal to 2022 and y square minus x is 2022 again? So how many pairs we can have? It's going to be integer, I think. And if you subtract, see if you subtract it, because they both are equal. So x square plus x minus, or x square simple, x square minus y square is going to be y minus y plus x equal to 0. So x minus y into x plus y, and we have again minus x minus y. So we can take x minus y common, and we have x plus y minus 1 equal to 0. So x is going to be 1, or x plus y is going to be 1. Now these are the two conditions we have, and we will use it in any one of this equation. So x equal to y, if we observe, use, so x square minus x equal to 2022. And this is going to be a quadratic equation. They are asking real number. So let's just, we have to count it. Okay, so x is going to be 1, and this will give you, say this is negative. Okay, so if you observe b square discriminant is going to be positive and two distinct root. Okay, you will get b square minus 4 is not going to be 0 here. So since two distinct root, so two pair from x equal to y. Now x plus y equal to 1 we have. So we can write y equal to 1 minus x. So we have x square minus 1 minus x whole square, not whole square, all of this equal to 2022. Again we have x square plus x minus 1 minus 2022. X square plus x minus 2023 equal to 0. Again b square minus 4ac, if you observe b square and 4ac is really big positive number, just like the last one. So it's positive, again two distinct pair, okay, because this is completely different prime number, and that one is also. So we have again two pair, So we have x2 values, and accordingly we have y2 values. So we have total 4 values. Okay, so 4 real numbers we have to satisfy this two equations, non-linear two equations. You can solve, you can find the roots. Okay, but that's not going to be integer. Next one. A square is inscribed inside a quadrant of a circle. The circle has radius 10. What is the area of the square? If we drop a perpendicular, this is going to be a over 2. And if we join this, this is 10. Still we have a small gap. So I think what we can do here, this is 45 degrees. Huh? So this is 45 degrees. So this is a over 2. This is going to be a over 2, right? And this is a. This is also a by 2. And this is 10. Now we can apply Pythagoras theorem. Yeah, right. We got the idea. So what we have here, we have 3a over 2. We have 10 here, and we have a by 2 here. So by Pythagoras theorem, we have a by 2 whole square plus 3a by 2 whole square equal to 10 square. Okay, we just need a square. No need to find a. So a square by 4 plus 9a square by 4 is going to be 100. If you add it, it's going to be 10a square by 4 equal to 100. 1 0 is cancelled out. Cross multiply, we get 40. So a square is 40. And we have the answer. Okay, question number 21. The perimeter of logo is created from two vertical. So these are the two vertical straight edge, two small semicircles. So these are the two small semicircle and two large semicircle. Okay. Now both the straight edge is 2 and 2, and the small circle have length also 2. So what we can do, just a second, just copy half of it, because the logo has rotational symmetricity. So we'll just count one, and we have, okay, we will double it. So radius is going to be 1, and this whole thing is 2. This is 2. If we draw this way, it's going to be radius of, or diameter. First of all, it's diameter. So it's going to be 2 root 2, right? A and A, this is A root 2. So the half of it is going to be root 2. So radius is root 2. Now, if we find this area, if we find this area, and we find this isosceles triangle area, okay, add this two and subtract this semicircle, we are done, right? So what is the area of shaded region? Area of shaded region is going to be uh, area of isosceles triangle plus area of larger semicircle, not yeah, semicircle, sorry, semicircle. I was thinking it's a quadrant. So largest semicircle minus area of a smaller semicircle. And this will give area of isosceles triangle is half into 2 cross 2 plus area of larger semicircle is going to be half pi r square, so root 2 square, minus area of a small circle is half times pi 1 square. Why? Because 1 is the radius, okay, and root 2 is the radius for them. So 1 2 is cancelled out, we have 2. This will also cancel, we have pi and minus pi over 2. So what we have, 2 plus pi over 2. Now we have to twice it, so the total area of the logo is going to be twice 2 plus pi over 2, which gives 4 plus pi. That's the answer. Okay. Next question. Okay, question number 22. How many pair of integer x and y satisfy the equation? This is the given equation, right? So what we can do, there are two square root, right? So we can square both sides. So it's going to be x minus square root of x plus 23 equal to a minus b whole square. So a square is going to be 8 plus y square minus 2 times 2ab. So 2 times ab. So it's going to be 4 root 2 y. Now, what we can do, we can bring all the integer one side. And this is to the other side. Now this is integer, this is root 2 form. This is also integer, not non-integer, or can be integer, doesn't matter. We don't know that, right? Okay. So, but this side is always integer. Okay. And this two must be equal because it will give you some number and this is already one. Okay. So if this is the case, this integer part must be 0. So we can say x minus 8 equal to y square or x equal to y square plus 8. Okay. And this side is also going to be 0. So you can just substitute. So y square plus 8 plus 23 is going to be 31. Is going to be 4 root 2 y. And now we square it. So y square plus 31. And this side is 16 times 2, 32y. Okay, so we get y square minus 32y plus 31 equal to 0. So we have y minus 31 into y minus 1 equal to 0. So y could be 31 or 1. Both are integer. We have to check one more time. Now, what is x value in this case? So x value is going to be 1 plus 8, that is 9, or 31 square plus 8. Now, if you observe 31 square plus 8, 9, first let's do with the 9. So we have on this side is 9 minus 32, right? X plus 9 plus 23. If x is 1, y is 1, then we have this case. And this will give 9 minus 4 root 2, right? And if we since we squared that, then can we simplify this one? So if you observe, it's going to be 2 root 2 whole square plus 1 square minus 2 times 2 root 2 times 1, right? And this gives 2 root 2 minus 1, which is correct, what we have already, y equal to 1. This satisfies. Now for the next one, if x is 31 square, so this is going to be 31 square minus 31 square plus 23, which is not much difference. And this side, not much difference means 2 root 2 and you have minus 31. Now this is going to be negative and output of square root is always positive. So, okay, we can't use it. So this is the reason we have only one pair and x comma y is going to be 9 comma 1. That's the answer. Okay. Next one, next question. In question number 23, we have this rectangle, right? Let me copy this rectangle. So we have this rectangle, area is given, and we have to find area of the complete triangle. We'll use similar triangle property. So remember, if area is given, this is going to be root 10. Okay, and this is going to be 3 root 10, and this is 2 root 10, and this is root 10. Now if you observe this length, okay, this length is 2 root 10. So it's 1:2 ratio. It means this is going to be root 10 over 2. 1:2 ratio, right? And same way, if we draw this vertical line and let assume this is x, this is y. So this length is going to be 2x. Now on this side, if you observe, this is going to be root 10 and this is 2 root 10. Now, previous one was 1:2. This time we have 2:1 ratio kind of thing. So this is 2 root 10. This is going to be 4 root 10. And same way, if this is y, okay, this is going to be y over 2. So we can just compare both the sides. Is 2x going to be y over 2 or y equal to 4x? Now we also know that x plus y is 3 root 10. So we have 5x equal to 3 root 10 or x equal to 3 over 5 root 10. Now we have to find the height. So height is 3 root 10. That's the complete height plus 3 by 5 root 10. Wait, not 3 by 10. It's going to be, wait, this is x. So it should be 2x, 6x. Because this is 2x length. So we have to use 6 here, twice of it. If we add it, so 5 times 3 is 15 plus 6, 21 by 5 root 10. That's the height. And the base is going to be, base of the triangle is square root of 10 over 2. But rest all is 10, 1 times, 3 times, so 4. 4 plus 2, 6 plus 4 is 10. So this is going to give 21 root 10 over 2, which is same. So area is going to be half into square root of 20. So 21 is square root of 10 by 5 into 21 is square root of 10 divided by 2. Now we have 21 is square, we have 10, we have 2 and 5 times 2 is also 10. So we have 441 divided by 2, which gives 2, 2, 0.5. Whatever it is, unit, square unit. Okay, that's the area. So what we applied similar triangle and ratio wise. So if you have the ratio, and this is the tricky part, like we know x and y, and relation between x and y two ways. So that have two linear equations, and we can solve those two linear equations to find x or y. Okay. From there we have the height, and we already have the base directly. Next question. So in question number 24, the number x, y, p, q are all integer. X and y are variable, and p and q are constant positive. Okay. The four positive are related to four integers are related to x, y equal to px plus qy. We have to find y maximum value, and we have to find y minus x. So what we can do, we can factorize it, and we can write x and y in terms of p and q. So xy minus px minus qy equal to uh, what we can do, equal to 0. So if we take x common, we have y minus p, and we want y minus p again. So if we add pq here and we take minus q, so again we have y minus p. So what we have, x minus x times y minus p. And if we take minus q common, we have y minus p again, and we have pq on this side. So x minus q, y minus p equal to pq. This type of factorization, you always say like hyperbolic curve. This is going to take, or simple in Diophantine equations. Okay, when we have integer solutions. Now, if you want to work, if you want to maximize y value, we have to assign all pq to y, because we can write x minus q equal to 1 and y minus p equal to pq. And this is how we are assigning highest value of y minus p, because we have to maximize y. So y is going to be pq plus p, and x is going to be 1 plus q. And if we subtract, and what we have to find, y minus x. So y minus x is going to be pq minus q plus p minus 1. Okay, I just rearranged. So if we take q common, we have p minus 1, and we have 1 times p minus 1. So this gives q plus 1 times p minus 1. And this is the answer. Go through. Next question. A drink carton is formed by arranging four congruent triangles, and this is what it is shown. And this smaller side is 4, 4, and on the larger side is 10, 10, and 10, and 10. We have to find the volume of this carton. What we need, say, for any like pyramid shape, this is what we have. Okay, we have to find the base area and we have to find the height. To find the height, we can draw perpendicular because this is symmetric diagram. So we can have the median, and from the median, this line will be somewhere, okay, on this side. Okay, we can also draw this line. I will explain why we need this triangle actually. So let's just start with let us say this is height h. So and PQR, let us say this is T. So in triangle PQS, this is what we have. This is 10, this is 10. We want ST, okay, and ST and TR are going to be same. So TS, this is going to be 2 and 2. So ST is the square root of 10 square. Simple Pythagoras theorem, which is going to be perpendicular because it's an isosceles triangle, so by symmetricity. And we have 2 square. So 100 minus 4 gives 96. Okay. Now, what is the area? So the area of base is going to be half time base is 4 times height. Height is going to be ST only, right? So if this is the base 4 and this is TS, which is root 96. So we have 2 root 96. That's the area of base. Now we have to find the height of this pyramid shaped carton. And for that, what we can do, we have this triangle, right? Which is R, S, and T. This is the square root of 96. This is the square root of 96. This is again 4. If we divide it, this is 2. So again an isosceles triangle. And we have to find this height, D. Why we are trying to find? See, because after finding this, we can find the area of this triangle. And from this, we can also compare this height. Because there are 3 ways to find any triangle, okay, area. Like if you use this as a base, we have this as a height. If you choose this as a base, we have this as a height. So this is how we can find corresponding altitude or height. So what we can do, let's assume this is D. So TD is going to be square root of 96 minus 2 square. Since we are squaring it, so we get 96 minus 4 or a square root of 92. Okay. So since we have a square root of 92, we can find the area. So area of triangle PSR is going to be half time root under 92, which is height, and base is 4. And this should be equal to half time root 96. That is base, and height we have to find. That's the height of the pyramid as well. So half and half will cancel out. And we have h equal to 4 root 92 divided by root 96. And now we can find the area. So the area of, not area, sorry, we have to find the volume. So the volume of carton carton is going to be 1/3 because pyramid, so it's going to be 1/3 area of base times height, which is 1/3 area of base is 2 root 96 into 4 square root of 92 by square root of 96. Okay, so it's cancelled out. We have 2, we have 4, 92 is actually 23, so one more 2 will come and square root of 23, and we have 3 here. So 16 root 23 by 3. This must be the answer, which is option. So this is how we tried. What we used, area of isosceles, or throughout area, how to find the area of isosceles triangle. Using Pythagoras theorem, we can find the height, and Again, using the area of triangle, like, which is half time base times height, we can find the height of the pyramid. Okay, then we have the volume directly. Okay,